Solving trigonometric equations. So we're going to start out with a pretty basic one where we have cosine of theta equals 1/2. And you may be saying to yourself, all right, well, 1/2, that's one of those ratios that comes out of these trigonometric functions quite often. So initially, hopefully we're thinking to ourselves, okay, well, if I plugged in pi over 3 into cosine, it would produce a positive 1/2. So that's a great starting place. The other thing we have to be a little bit aware of is we're trying to find absolutely all of the solutions, all of the exact solutions here. So I like using this phrase, all students take calculus. And what this helps us remember is which quadrant things are going to be positive in. So all of the trigonometric functions are going to be positive in the first quadrant. Only sine is going to be positive in the second quadrant, tangent in the third, and cosine in the fourth quadrant. So this pi over 3, that's an angle in the first quadrant, and cosine is going to be positive at that angle. But we also need to find an angle in the fourth quadrant where cosine is also going to be positive. To do so, what we're going to do is use that pi over 3 we already found and place it in the fourth quadrant as a reference angle. So now what we want to do is calculate the angle that would wrap all the way around into the fourth quadrant that would have pi over 3 as a reference angle. So what we want to do that calculation is we're going to find theta has to be, we're going to take the further side of this angle, which would be 2 pi, and we're going to subtract away our reference angle. So we can do this calculation as 2 pi minus pi over 3. And with a little bit of simplifying down, we're going to get pi. 2 pi can be rewritten as 6 pi over 3 minus this pi over 3. Just rewrote our 2 as 6 divided by 3, so we get this common denominator going on. And then as we combine these together, we're going to get 5 pi over our common denominator of 3. So these are the two angles that would produce a positive 1/2 when we plug them into cosine that are in the first time around the unit circle, between 0 and 2 pi. However, we do have to remember that we're looking for all the possible solutions. All right, so what could happen is we could wrap around extra times around the circle and end up at the exact same spot, thinking coterminal angles. So to account for that, what we're going to do is take our pi over 3 and we're going to add 2 pi, which is the period before cosine starts repeating itself, multiplied by k, where k is an integer. So either positive or negative whole number, or it could be 0. All right, we're also going to do the same thing with 5 pi over 3, that we're going to take 2 pi, the period for cosine, and multiply that by some integer k. So our overall way to represent these is going to be pi over 3 plus 2k pi, and 5 pi over 3 plus 2k pi, or 2 pi times k. Sometimes you'll see these written with the k in the middle for whatever reason. All right, so hopefully this helps out as you're working on finding all the possible exact solutions for some of these trigonometric equations. Good luck.